Good morning. I hope you are all ready to rock week two of virtual learning. I overall am super proud of you guys for the work that you put in week one. I know it was not an easy adjustment for any of us, and I think you guys did great. So I think this scenario, we're going to make the best of it and we're going to have some fun along the way. But we do also have to put in some work. So I did put up a spreadsheet of missing work, and it includes both classes. So it's my morning class and my afternoon class. And I noticed there was quite a few from the first day, the science assignment, which was to not only fill in your book answers, which I'm going to go through those answers now, but also to create or show me, I'm sorry, from home, an example of a mixture and a solution. And I also wanted to clarify a few things. I did send back some people's submissions because they didn't have it quite right. And I wanted to clarify a few things about mixtures and solutions. So as I go through these answers, I'm going to talk about it. Before I do that, a couple of other quick housekeeping things. Again, Mrs. Chris and I combined a sheet, which is also attached, and that sheet has conference times that you can set up to meet with either Mrs. Christ or myself. And I can probably fit two, no more than three people in a time slot. So if you want to hop on with a friend for a math lesson, that's fine with me too. I'm going to try to set them all up through Google Chat. So if you have not already been to the chat room or the chat feature, it is in your Google app, Google Apps. And if you click on the drop down box and you scroll down, you will see chat. And if you click on there, you were automatically added to either my homeroom or Mrs. Chris' homeroom. And that's just kind of a fun place for everybody to kind of catch up and see how things are going and just kind of pop in throughout the day. That's not really work related. The only thing that I will say is you can go there and I can send you an individual message or a group of you an individual message and set up a video chat right there. So I'm going to try to do that because I think that might honestly be the easiest way rather than sending back and forth links through email or Google Classroom. So that's the one thing I'm going to be creating today, a YouTube video or a couple of YouTube videos for some of the upcoming math lessons. For those of you following Pearson, we're going to wrap up topic 8 this week. There's only 3 lessons left, so that's kind of the goal for this week. And like I said, 8, 7, and 8, 8, I'm going to create my own videos. And I'm also going to find a couple of videos to post as some extra support for you for those lessons. As I mentioned, check your email, please, because if there's something specific I'm looking for you to do or, that I need from you, I need you to be constantly checking your email. I mean, not constantly, but a couple of times a day in case Mrs. Chris or I or one of the other teachers is looking to get a hold of you. And check Google Chats as well. If you have any questions, obviously, please reach out to us. That's what we are here for. But we are also in meetings actually with Mr. Collis and some of our supervisors just to talk about things that are, working and things we might want to change and things like that. Oh, I'm going through the assignments on Seesaw. It is taking me a little time. There's a lot of assignments, and I'm looking at each individual one very carefully. So I might make comments and send it back to you if something is not correct, like I mentioned with the mixtures and solutions. So take note of that, please, and redo it if you can. And same with the math, because there's a couple of math in there that I saw that weren't 100% correct. Um, Great efforts, great attempts, but couple changes that need to be made. So then you can resubmit it for me to review. Okay. And I haven't gotten to all of them, but I'm getting to them slowly but surely. And just pay attention to deadlines because not everything that I post is due that day. For instance, the Newsella article that I posted today will not be due until Friday, but you need to manage your time at home so you make sure you get that stuff in. Okay, so with no further delay, let me go over the answers to the book. Okay, on page 110, this is your science book. On page 110, they talked about conductivity, thermal and electric. And question 9 said, why would holding a metal umbrella during a lightning storm be a bad idea? It's a very bad idea, by the way. And the answer is really that metal is a good conductor of electricity. You probably know the story about Ben Franklin, right? And that lightning, which is pure electricity, could hit the metal and cause you harm, cause you a lot of harm. So you never want to be caught with anything metal while you're, outside if there's a threat of a lightning storm. Question 10. The spoon in the left hand pot of boiling water is made of metal. Metal went in that slot. It is a good conductor of heat and electricity. Okay. And then jumping down, if you did 11, um, you probably did not do 11 because that was kind of a hands-on, but it conducts electricity. That was the answer for that. What could you say about the material? It conducts electricity. Maybe you knew the answer to that without doing the experiment. Number 12. Okay, so conductors, like metals, easily move heat. Insulators, like pot holders, limit the transfer of heat, which is why you use pot holders to get things out of the oven so that you do not burn your hand. Okay, so rubber, as you've read about and we talked about in class, some of you, we talked about this in class, is a good insulator. Okay, so dissolving and evaporating, we're now page 112, 113. Okay, if you were looking at that graph, the answer to number 14, describe how long it takes different volumes of water to evaporate. The answer should be something like the more volume there is, the longer it will take to evaporate. So that just is kind of common sense, right? The more you have, the more there is, the longer it's going to take to evaporate. And question 15, how long does it take different temperatures of water to evaporate? So substances that are at warmer temperatures take less time to evaporate than those at cooler temperatures. So think about a boiling pot of water. When a pot of water starts to get really warm and you start to see the steam coming off of it, and then it's really boiling and you see a lot of steam, that's evaporation. That water is hot. So hot water is going to evaporate quicker than cooler water, and that applies for any substance that has a warmer temperature versus a colder temperature. Number 16 lists 4 properties of matter that can be used to determine and describe an object. We talked about a lot of these earlier in the chapter. It could be anything: color, flexibility, hardness, solubility, meaning how easy it dissolves into another material, a texture, size. Those could all be used. Okay, now exploration 2 is mixtures and solutions, and this is where I saw that there was, I think, some confusion. Okay, so a mixture is defined as a combination of 2 or more different substances in which the substances keep their identities, and you can fairly easily separate things in a mixture. Okay, some of the answers I was getting, I let go, such as, ice cream with sprinkles on top, but that's not really mixture because it's not really mixed together. So you want things that are mixed together. That's why they always use trail mix. And I use the example of Lucky Charms, because you can pull out all those different color marshmallows. Salad. Okay. So though that's a mixture. And it says in a mixture, each part keeps its own properties. Have you ever accidentally swallowed some ocean water? If so, then you have tasted a mixture, water and salt. Mixtures can be separated. If you leave a dish of ocean water out in the sun, the water evaporates and a small pile of salt remains. And I know we've talked about that. In fact, the goal was to do an experiment like that in class, but guess what? I think I will do that here at my house. I'll leave it out and then show you in a few days what it looks like, okay, when the water evaporates. So name a mixture you may find at a meal. There's a lot of different answers, but you might have picked soup, trail mix, cereal. The cereal by itself might be a mixture. Cereal with milk is a mixture, okay? Pizza. I know some people said, peanut butter and jelly. which that would be an example of a mixture. So there are a lot of different types of mixtures for sure, but think about them, like I said, being a little bit more mixed together, but being able to easily be separated. Okay. Number 18, I'm going to fill in the blanks here. When particles are blended together, they form a substance called a mixture. When this happens, each particle keeps its own properties, was the next blank. One thing that is special here is that the particles can always be separated. A good example of a mixture is salad, even fruit salad. Okay, that was page 115. Okay, so then page 116 talks about solutions. Okay, and it says a mixture that has the same composition throughout because its parts are mixed evenly is called a solution. All right, so think of lemonade, ocean water, ocean juice. So with a solution, the parts are mixed together evenly. They can be separated. It's not always easy to do. It's not something like if you took a glass of orange juice, you're not going to be able to separate the parts of the orange juice. But can it be done? Yes, technically it can be done. Um, I know people had, a couple of people had put um, water was an example of a solution, but water, in fact, is not an example of a solution. Now, if you had seltzer water, that would be an example of a solution because you're actually dissolving carbon dioxide into the water to make it bubbly. So that's a solution. Um, Flavored water is a solution. Some people gave me Gatorade. That would be a solution. Okay, but plain water by itself is not a solution. 19. Let's see. Oh, and of course, air. Air was a great example of a solution. And I know one or two people put that um, too, and a couple people put the soap example. Um, but we're talking dish soap um, or hand soap. So that was, those were also two examples of solutions. So fill in the blank. A taco, I had one last night, is a good example of a mixture because all of its parts can be seen. Lemonade is an example of a solution because its parts are so well mixed that they can't be easily seen or separated, but they can be separated. So I just wanted to make everybody aware of that. Water, which is a combination of hydrogen and oxygen, it can't be separated without it's no longer water at that point. Okay, so just a few little differences for you guys. All right, and then page 118, number 20. Identify how the two mixtures below were sorted. You could have said, with a fork or your fingers, you could easily separate the ingredients. Now, the bottom picture with the workbench and the metals and the non-metals, honestly, you need a magnet for that because the magnet would attract the metal parts and pull those apart. Okay, and that's how that could be separated. All right, and then on page 119, how would you go about separating materials found in an unorganized desk drawer? Well, there's a lot of ways you could separate these, and I have a lot of unorganized drawers here. But now that I'll be spending more time at home, maybe I can start to organize them, right? So the first thing that you could do is there's a lot of ways you could do this. You could, pull out the large objects and sort those first, and then sort the smaller objects. You could break them into how you use them. Let's say you have, writing utensils, so crayons and pencils and pens, and erasers could go in one section. And then maybe you have like, binder clips and paper clips and rubber bands, things you use to hold things together in another section. Um, so there are a lot of ways that you could, but I guess the best thing is to really kind of form a plan before you're organizing those. All right. And page 120. Okay. So you read about alloys, which are very important because honestly, if we didn't have alloys, we wouldn't be able to have half of the structures that we do, right? Because those are two metals which are melted down and combined, and together they form extraordinarily strong structures. So steel is really one of the best and strongest examples of an alloy. Question 23. Says the engines of airplanes are made of materials called superalloys. Do some research on superalloys and where and why they are commonly used. So they are typically a combination of nickel and cobalt. And I showed you guys the periodic table of elements, and nickel and cobalt are both um, their own elements in the periodic table, but combined, they make even a stronger element, and this is called a superalloy. And they are useful in airline planes because they function at extremely high heats. They're very tough, they're very durable at very high temperatures, and obviously, an airplane or jet engine gets really, really hot. So that's the benefit of a superalloy. And question 24, what is a mixture and why are solutions considered the best mixed ones? So a solution is, again, a special type of mixture. It's still a mixture. It can still be separated, okay? So a mixture is any combination of two or more things in which each one keeps its own properties. Solutions are mixtures that are so well mixed together that separating those are difficult, but it's not impossible. So when you think about some of those solutions, like we said, orange juice is a good example. Can you separate the components of the orange juice? You can. Is the sugar in the orange juice still sugar? Yes. Is the actual orange juice still orange juice? Yes. So it has its own properties, but it's so well mixed together, it would be very difficult to separate that. So that's the difference, really. A solution is a special type of mixture. Okay, so I will be, like I said, creating more videos today, probably creating some science videos as well to go over the next set of answers. And we will take it from there. But look forward to working with you guys this week. Thanks for watching.